I'm going to speed run through the agenda because we have a lot of really, really great content today. So first off, we are going to have Eugene, who will tell us a little bit more about how the Lido V2 rollout went, and some of the design decisions that went into the upgrade of the protocol, and how withdrawals and exits are going, as well as a really quick demo of withdrawals on mainnet. Then we're going to have Will tell us a little bit about Lido on Ethereum and the upcoming onboarding wave. And Sabrina from the VaNOM workstream is going to give us an update on the validator and node operator metrics tool that Lido contributors have created. And then we're going to have an intermission, and I'll talk a little bit about the rest of our agenda with guest appearances from 2 node operators who are going to help us troubleshoot late proposals, and Rated Network, who's going to give us insights into their Solar Staker participation on Ethereum. So first up, we have Eugene with the Lido V2 rollout.
Okay, hey everyone. So let's start. So I wanted to tell more about things that were not covered by all the blog posts, and things that got overshadowed, and things that actually enabled a lot of cooler features like staking router that has been buzzed over a lot of times. And how those decisions were made, focus on buys, and of course, as you said, give overview of how it's working right now. So let's get started. So if some people closely watched the Lido infrastructure and protocol infrastructure, they might have noticed that Lido now has 2 oracles. So it used to be 1, now it's 2, and for some people it became confusing as to why it happened. So in short, it happened because we now have a lot more information to report back the chain. So the legacy oracle, which still operates in its shell of an oracle, used to only report back the rebase delta, the number of validators, and the timestamp of the report. Just the middle information needed for the protocol and chain to update STF balances for every holder, and just so that everybody has updated information and the protocol is running. But now that we have withdrawals, a lot of things came true. We now have withdrawals data. We now have that is protocol uses to activate the withdrawals. We now have possibility of validators exiting that's needed for a huge amount of huge withdrawals, right? And we also now have a staking router, which brings us to the point that a single oracle or even a single transaction cannot fit this much data to be put in the protocol, but it's still all needed. So to address this, one oracle was split up in 2. One is accounting oracle that handling accounting, handles rebases, handles withdrawals, handles balances intervals, and I'll touch that later. And another one is the validator exit bus oracle, which handles exits of validators, and it packs very tight data, mentioning the staking module IDs, the node operator IDs, and public key for each validator. That's a huge amount of information. And because it's an array, it can be arbitrarily long, and we cannot be sure that it will fit with other accounting data. So it had to be split up. But there are actually other reasons, but you can see here the main one. There's just the sheer number of data that is needed for the protocol to function with withdrawals. So the other reasons would be the domain separation, because now that we have so much information, we want to separate, and domain separation will come up further. We wanted to separate different domains of responsibility because those oracles They respond to different things. They operate with different parts of the protocol, and one of this is one of the points of this is the security increase of this domain separation, because now we not just have different machines running those oracles, but also different consensus committees, which prepare the reports, which agree on reports, and then push them on the protocol, are separate entities that mind their own domain. And basically what we have now is, I would say, an Oracle framework to increase the amount of oracles as we need, but that, of course, that's not something we would like, but something that can happen in the future, right? And that also enables us to have async reporting. So basically, we now have the reporting once a day for each one, but we can increase or decrease the period, and those reports can be processed asynchronously. And with the data patching and data packing, we now can reduce some gas. So if we try to fit all of this into a single transaction, we would quickly run out of the block space, and that would cost a lot. All right. And also other thing that were mentioned quite a lot in Twitter space, especially with the Celsius withdrawals, are the Lido buffers. And I first like to have a look at the old buffer, and I don't think it's very much old buffer system. I don't think it's all much different from the newer one, and you'll see just a bit later why. But for the older Lido protocol, it used to be that a buffer was just part of this triangle of a fund circling. So basically, people would deposit into the buffer their Ethereum. They would receive back STETH, and this Ethereum would be used to onboard validators, and then all the rewards to be consensus layer rewards, to be priority fees, rewards from math. They will be collected and then used with the user funds, again deposited to onboard more validators. So with V2, this scheme is not much different, but underlying, of course, became a bit more complicated. Now that the users are able to withdraw from the protocol, we don't need to exit validators if the user wants to withdraw their Ethereum from the protocol, because we can take from the deposit buffer and be done very quickly. So this actually enabled us to process Celsius withdrawals without exiting a single validator. So I think that was a great success. And I don't think that there would be an actual possibility to have any other architecture, just because if you would try to greedily, once we have like 32 Ether in the protocol to greedily onboard validators, we would quickly run up the gas cost for this operation. So it's done, those onboardings are done in batch and are done in timely manner. And this allows us to smooth out the funds moving through the protocol. This means that I think, yes, that's gonna cover it. This will be covered in detail. So this actually helps us to smooth out funds movement, meaning that people who try to stake and then unstake will not be actually, won't affect protocol. So, and a huge amount of sums, if it be staking or unstaking, but unstaking we'll talk about a bit further. Those funds will not just trigger a huge amount of stuff happening, this deposition into the consensus layer. No, this will be done step by step, just gradually, and this prevents us from our numbers like APR jumping or just going down. And we also have walls, I think. Let's see if you can move back. No. Yeah, we have. So we have reward walls, and walls are also an interesting part of this scheme, because one would think that it's just easier to just hold all funds on the address of the main contract of the Lido contract, but having individual vaults for purposes like we have execution layer rewards vault that holds priority fees and MEF rewards. We also have withdrawal vault, which, don't be confused, is not exactly connected to withdrawals from the protocol. That's the vault that basically rewards from the staking and also Ethereum unstaked from the validators comes through. So what's the purpose of having those vaults? It's basically that they're tightly programmed, they're hard-coded, that only a very limited amount of actions can be done with them. That means that even if some parts of a protocol are compromised, the actual actions with the vaults are very limited, and you can just take out funds even if some parts of the protocol are compromised. So yeah, I think that's really covers it. So let's go next. Oh yeah, and as you can see on this Dune dashboard, this is buffer performance, and you can clearly see how Celsius withdrawals of around 500,000 Ethereum were processed, and you can see that just before that we got a lot of Ethereum in our buffer, and that covered the whole amount of Celsius withdrawals, and we did not have to exit a single validator. And you can actually check out the full dashboard by this QR code link. The next thing is the actual withdrawals. And the good question came is why there are two steps. And I think one important point that I'd like to mention that I think is sometimes escapes the blog post is that technically STF total amount is changing constantly because it represents the total amount of Ethereum in the protocol. That means that with every reward on consensus layer of Lido validators, every single change, if it's reward or slashing, doesn't matter, this value changes. But for technical reasons, for reasons of cost, this only gets reported to chain once a day so far. And while this was okay for V1, with withdrawals and but unfortunate thing can happen. So if we process withdrawals just as is, as we have in our protocol, just so you came and you just tried to withdraw and we just gave out your funds from the buffer, then knowing the current state of consensus layer, seeing that some Lido validators got slashed, and I think that's a very, not just an unfortunate, but clearly an impossible event for now, definitely. So you see that and you gain an advantage. You go and you try to withdraw because protocol still has the previous and actual share rate for your staff to Ether, and you get an advantage if you try to be the first one. But this creates a lot of unfairness in the process, and that is something that we wanted to escape. We wanted to make it as fairly as possible. And well, there are also things that if we don't have enough in our buffer, we need some validators to exit, and it takes some time so that we get the staked Ether back from them and can be distributed to withdrawing users. So in a few words, just how the finalization works. Basically, we finalize, meaning that we make a withdrawal request claimable request after we just give it like a day for Oracle to report. And there's a whole part of protocol functionality that calculates the share rate, and if in event of a slashing, the Oracle will capture this relate to the protocol, and you will get you won't get more than there was in the consensus layer. Meaning that if you try to if you see this event on the consensus layer, you try to skip in the front, you still get the same as every user. So that means that you don't have to monitor the Lido state constantly, and you can be safe about your funds. You can just if you see something is up, you just go in and withdraw if you'd like, and you'll be fine. And that was our goal, to make it as fair as possible. And plus, this time distance gives us again a smoothing effect of funds movement, meaning people that try to stake, unstake, just move funds through protocol, they will just run into the gas cost, and they won't hurt us in any way. And in this process of between withdrawal request and claiming, you also get an NFT. So apart from it, the NFT being having a very cool picture, there's also a very good reasons for it being an NFT, is that it basically represents your receipt or your place in queue to claim Ethereum back from protocol. And as a very good as any good place in queue should be, you should be able to sell it. You should be able to transfer it to somebody, maybe, and this gives us a cool opportunity to not us, but it gives the users of a protocol ability to create secondary markets and have continuous liquidity of their assets, even if they're still locked as NFTs. You still have liquidity. You can still try to sell, and I'm sure that someone will try to buy it from you if you're really, or you can buy if you really want to get to the front of the queue. So yeah, and basically, when developing this this concept, we realized that it's very much is an NFT, and if it clocks like NFT, why shouldn't it be an NFT? So we added a picture on top of this, and I think the picture and animations are very cool. So yeah, and oh yeah, and the one last thing that I like to mention is that seeing that assets in your protocol that they correlate or they fit into the existing standards is, I think, is very healthy for Ethereum, because it allows other protocols, other developers to interact with your protocol. And I don't know in which way, but I'm sure somebody will figure out something interesting, and it will be easier for them if you follow the standard. It will be easier to them to incorporate our code, our protocol into theirs. So it seems that I skimmed very fast, though I thought that I might not have enough time. But I do have a UI demo for you. So I was told in the last call that we showed a girly version of our UI, but right now it's on mainnet, it's finished, and it has final form. So, and there's also a little thing that I'd like to show and explain in more depth. So let's get to it. Okay, let's see. So here I have the latest UI, and I even have some STF. So I think the cool part is, let's just try a bit more, is that we can actually skip the queue and use aggregators to go, like you can go to 1 inch, you can go to co-swap, bar swap, and exchange, and just use the DEX to exchange your STF to ETH. But if you'd like to use a protocol, that's also fine. You see that you get just a bit less because you have to pay fees. But I personally think that this amount is negatable. Sorry, if you really need these funds now. And it may happen that in rare events of liquidity or rare events of chain, that you actually can get a better rate. That's something that's possible theoretically. You can get a better rate with aggregators than on Lido, because with Lido you only get 1-to-1, and with the finalization principle it upholds because you still get just 1-to-1, but it might be just a bit less because it gets corrected by the actual value from the consensus layer. But let's use Lido for once. So that's the interesting part. That's my favorite part, is that we're with withdrawals, we're using the permits. Permits are basically our gasless approvals, and you don't need to approve your tokens, send a transaction, and then send another transaction, or before that, wait for the other transaction to finish. Now you just have to sign a request. But still, I think MetaMask has a. I don't think you can see my MetaMask, but I think MetaMask UI has ways to go, and I'll show you just a bit later. Because I think it's a bit confusing for users, and it can be much better and much more welcome. Okay, so now I'll wait for the transaction to finish. Oh, that was fast. And we now get an NFT. Let's see. Oh, great. And it should be appear in here. So I already have one NFT that one withdrawal request that I requested earlier, and I think it was just about this time yesterday, and it's ready to claim, and we can go through it. And for this, you don't need to any additional operations. You just press claim, run the transaction, and you're good to go. And in the process, the NFT that you had is burned because it's sent to a 0 address, and you basically cannot claim it anymore. Yeah, because it's burned. But if you like your NFT, you can of course keep it, or you can wait for an opportunity, sell it, or send it to your friend. So it's still very, very much liquid. Okay, and go. So yeah, about the permits, as I said, they're a bit confusing, I think, and I'll just very quickly go through what those values mean. And also said that, yeah, they're gasless, they're secure, and with V2, they're available on STF and WSTF. And unfortunately, they're not available for every token or for every protocol. That's a very much new technology, but I'm glad the Lido is on top of the wave with this. Because personally, I hate paying for gas, and I hate waiting for a transaction to finish. So yeah, this is the screenshot from MetaMask UI from my yesterday transaction, I think. And I don't think it does a good job. First of all, the value isn't way, and you can really compare it to what was on a website. The nonce, it just increases with every permit you sign and use. And the deadline, Lido uses the infinite deadline, but I think we might fix it or change it in just a bit later. Right now, it's a deadline for just very long, and I think MetaMask would do a great job if it actually showed the values in proper seconds and not just in the numerical, because I think that's pretty confusing. Yep, and I think that's all. I just got us pretty fast. Thank you all for listening, and I'm ready to answer your questions.
Thank you, Gene. I don't see any questions on the YouTube, and also nobody has their hand up in the Zoom call. So I think we can kind of go through because we're already a little bit behind schedule. Thanks a lot for the really great presentation. And also just something to remind people, the NFT itself is basically like a liquid position of your withdrawal claim. So if you ever sell your NFT, try to make sure that you don't sell it for the actual value of the withdrawal claim that it underlies. And if you send it to another address, remember that you need to claim with that other address that you sent it to. The NFT is the withdrawal.
Yeah, you will if you receive an NFT, you will see it in our UI in the claims tab. So we do not exactly implement transfer functionality, but you can do that with MetaMask if you add your NFT or with your wallet that supports NFT, and maybe I think on OpenSea as well.
Yeah,
but
for sure on OpenSea.
Yeah, but every functionality that relates to that's unique to Lido and Withdrawals is accessible in our UI. Right. Thank you.
Okay, thanks a lot. So next up, we have Will, who's going to tell us about the next Lido on Ethereum proposed onboarding round.
Hey everyone, I'm Will. I'm a contributor to the node operator management stream work at Lido. And as you mentioned, I'll be talking about the sixth wave of onboarding for Lido on Ethereum. So in terms of background and where we are today, in a post V2 world, the staking router is now deployed, and the curated operator set that everyone's familiar with is module number 1. And so this module currently consists of 29 node operators that are predominantly based in Europe and the US. And as of right now, the majority of these node operators are above the soft cap that is displayed on the Lido on Ethereum scorecard. So this is basically a goal that Lido on Ethereum node operators should not be in excess of 1% of total ETH staked through Lido. The average node operator is running 7,600 validators right now. And generally, these numbers are above the targets that are set out. So we're going to talk about sort of the initial steps that are going to be taken towards addressing this, as well as the process for the next onboarding round. And some important context here, the last Lido on Ethereum onboarding round was held just about a year ago. So a major reason for this is you may remember that staking inflows across Ethereum were stagnant a few times over the past year, just due to all the macro volatility that's taken place. But an important factor here is that the last onboarding round took around 3.5 months. And so there is a desire to expedite this process, which I will be talking about. So as sort of mentioned, we're excited to announce the Wave 5 onboarding. There's been 5 onboarding rounds previously, so this is the 6th. Applications are going to be open later this week, and you'll see the announcement on the forums as well as all of the Lido socials. So a basic overview of how this process works. The node operator management workstream works with a subgroup of the Lido DAO called the Lido Node Operator Subgovernance Group. This group consists mostly of Lido node operators, also a few node operators outside of the protocol, and together they work to coordinate the onboarding rounds for all of the curated protocols on which Lido operates. And so over the next few weeks, applications will start to be received. The node operator management team will coordinate meetings with the LNOSG to interview candidates. These meetings will have notes taken and potentially recordings available for other LNOSG members to review. And then there will be an evaluation that takes place where the LNOSG proposes a shortlist. So they will look at all of the applicants, look at the suggested criteria for onboarding, look at the state of the protocol and Ethereum overall, and then suggest a shortlist to the DAO. And it's very important to note here that the LNOSG does not actually make a decision. The DAO has final say. So the DAO could decide to accept the shortlist, modify the shortlist, decide there's not going to be an onboarding round, etc. But generally, this process takes at least a month to run, from applications to evaluations and then proposals on the forums. On the forums, there'll be time for discussion, followed by a snapshot vote and then Aragon vote, which allows the node operators to be onboarded officially into the protocol. Once onboarded and accepted by the DAO, there's a testnet period where new node operators basically learn how to run validators through the protocol. There's a time for monitoring, and then also a sort of test phase on mainnet as well, where a limited amount of validators are run. So among the goals for this onboarding round, in addition to just bringing on new node operators, one would be improving the diversity across execution layer and consensus layer clients used by node operators. Two, onboarding node operators not using public cloud as their primary server location. And three, onboarding node operators outside of the US and Europe. When Sabrina talks about the validator and node operator metrics in the next segment, you'll understand, I think, a bit more about why these are important criteria. So I alluded to this earlier, but there's going to be a slightly different process for this onboarding round in order to expedite the addition of new node operators. So it'll basically be run in two stages. And so for the first stage, node operators that reapply, and so they've applied in the past, they reapply for this onboarding round, and that were previously assessed high scores by the Lido node operator subgovernance group, could be evaluated sooner. And for those that are potentially evaluated, proposed to the DAO and then onboarded, be onboarded as soon as mid-July. So these node operators might be, they might have been right on the cusp of being accepted in a prior onboarding round, and there just wasn't enough slots available. But generally going to target around 2 to 5 node operators. Again, this would be a DAO decision to start the process of distributing stake and allocating new stake to new node operators. During this time, applications will still be accepted, and there's going to be an additional evaluation session held by the LNOSG, probably in late July, for new applicants, and then those that maybe were assessed but weren't accepted in this first stage, and then basically reviewed again. And so that would probably target around 3 to 5 additional node operators. So again, depending on what the DAO chooses to do, you could see probably somewhere between 5 to 10 new node operators brought on during this onboarding round. It's important to remember that over the next 6 to 12 months, there will very likely be additional modules brought onto the protocol through the staking router, whether these are DVT based with OBOL and SSV, or some sort of permissionless entry. In general, there's going to be many more ways to participate as a Lido node operator over the coming months. And so it's important to keep that in mind as we look to prioritize stake allocation to new modules in the future. So announcement will go live later this week. Make sure you're monitoring the research forum and Twitter. And if you haven't, you can click the first link, the operatorportal.lido.fi, to sign up for onboarding notifications. This basically will mean you get an email for any onboarding round that is announced. The second link there has some additional information on the thought process for the 2-part onboarding. And then the research forum is linked at the bottom. I'll include a link to the slides in the YouTube channel chat. But happy to take any questions, and excited to see all the applications come through. Thanks.
Thanks, Will. I don't see any questions. So Sabrina is next with a recap of all of the new cool analyses in the Q1 2023 report compilation for the validator and node operator metrics tool. Oh, actually, we have a really quick question, Will. When DVT?
So DVT will be a work in process on mainnet over the next 6 months. We're working with both OBOL and SSV, as we have been on testnet, to basically figure out exactly what modules might look like. But the goal is definitely to have DVT on mainnet sooner than later, cognizant of the fact that it's still pretty early in the tech cycle for both protocols. A ton of progress has been made, and it's going to be really exciting to have people on board on mainnet, hopefully by year end.
All right, thanks, Sabrina.
Hi. Hi, this is Sabrina. I'm also with VaNOM team. So thanks for joining me today. Today I'm going to share VaNOM. So This is our quarterly report for validator and node operator metrics. So in, oops, sorry. So in the presentation, I will quickly go through this. I will quickly introduce what is a VaNOM and how do we prepare the reports and what kind of metrics we cover. And I will quickly showcase the app itself. So VaNOM, this is, we publish this report at end of every quarter. And currently we have, we publish for Ethereum and Polygon. For Ethereum, we have been publishing reports since maybe end of 2021. And from this previous quarter, sorry, so Q1 23, we finally extend to also publishing for Polygon. And so who do we, who are these reports for? So in general, it's actually for, we want as much to the report to be useful for as much audience as possible. So for example, node operators and Lido DAO and ST asset holders, and also just wider staking community in general. So these are, if you want to check out the apps, these are the QR code to Ethereum ones and then to the Polygon one. And then I will continue to the next one, next slide. Okay, so how do we prepare a report currently? So the process actually is quite manual at this point. So we have three main parts of the data we collect. So first part is actually node operator, they will self-submit their self-submitted data from node operators. So give it for example, so if a operator, they have a cluster, say they have 500 Ethereum validators running on it. And so the kind, how they would submit the data, it would usually look like, so for these 500 validators, which execution layer client they use, and which consensus client they use, and also, for example, like which kind of server these validators are running on. And the second part of the data are easier to get, like we can just query on chain. So for example, like the actual active validators at the point in time. And the third part of the data is we also get data from other third-party providers. For example, we want to know the network status for so like a client diversity dashboard, or there is this really nice dashboard from Mega Labs for vegan chain informations, and also, for example, chain saves, what is that called again? Yeah, NodeWatch. Yeah, that's like some example like where we query the data. So once we get all the data, we basically put them all together and intentionally to publish the information at a Lido aggregated level. So we don't specify a specific how each node provider their setup is like, at least not currently. And for the report publication, we have two formats. One is PDF, that's where we started. Those PDF you can find all the report links on the forum. But I would highly suggest to just use the one which I will show later, like in the more interactive app. So just quickly show what are the metrics we actually cover so far. So obviously, client diversity is something everybody know is super important. And we also try to cover on, we also covers infrastructure. So for example, what kind of server they use, is it cloud providers, or it is on premises, or it's a dedicated server, and where are the servers located, in which country or which region. Jurisdiction is also a risk factor that everybody's keeping an eye on. So this, yeah, we also cover this information. And lately, from this quarter, we also try to add this stake distribution numbers. So why is it important? So one thing is, obviously, one thing is right now V2 is live, and how the stake is distributed within each module. So currently we have the curated module, and in the future we will have, say, like DBT-based modules. How are this stake will be distributed among different modules, and within the modules we will gradually to build out different metrics, how we can understand if this is like a good way for the protocol to progress. And as for the performance, currently we only gather data for Polygon side. The reason why we don't have for Ethereum is because since the data the report we only gather on a quarterly basis, and some of these numbers it doesn't make that much sense. But we are looking in the future that we can potentially mix some of this information, which can be updated more frequently. For example, like what Reddit is doing, like their performance metrics, effectiveness, this kind of information. We are also looking into a way to blend them into the report in the future. So so let's quickly to actually show you how the apps looks like. So if you scan the QR code, basically will take you to this page. And here you can select the quarter which you want to see a report. And then you will see how many, from basic information, like how many operators are participated in the protocol at that end of the quarter, and the average keys and some basic statistics here. And here is stake distribution. So this is as of end of March, our 29 node operators, how much validators they are running. And here the orange line is the soft target that Will has mentioned earlier. So ideally, we would want all the operators to be just not have over this limit. That's why we would like to have, so this is why we also, for this round of onboarding, we are considering to have a fast track, that so we can spread out the stake a little bit further. And so for other part, and so we also do some calculation for the stake distribution, like Gini coefficient and HHI. I am not going to, I don't plan to go through the detail that much, because I hope you guys will go read the report. And so we'll just continue. And here is the current Lido, how our operator, which kind of consensus clients our operators are using. So as you can see, Lighthouse is comparing to the overall Ethereum network, it's slightly less, but it's still quite a lot. And what's the difference is that a lot of Lido's operator actually using Vouch as in their infra. So this is something different. And yeah, and for execution layer, there's the here. So back to what Will has mentioned. Basically, this is the reason why we would like to reduce to onboard operators which is not using public cloud, because we have nearly half of the nodes and the validators are basically on public cloud right now, and we really would like to try to reduce this number a little bit. And as for the locations, this is also quite clear. You can see like the majority of the operators and nodes are in US and Europe regions, and not so much. I mean, there are some presence in the Asia region, but not as much. And there's nearly nothing in the South America. So for operators which is interested in joining this kind of onboarding, I'll just encourage you to come check out the report and to see, and so you'll understand a little bit where we are right now, and hopefully to just you'll know where we are right now. And if your setup can help with the diversification, I believe you will be able to get some extra points on that. Yeah, and so so I will then continue to about Polygon side. So Polygon is also the same, except we're only starting from this quarter. And for Polygon, this is a bit different. Our stake is equally distributed among the operators participating in the protocol. And as of end of March, we have 6 operators. And so in general, that means like all operators is getting something like 17% of the stake. And this is the amount of stake Lido have throughout the 3 months in the quarter. And some information on the operator performance. And this we currently only focusing on the checkpoints. We don't really have the information on the board and handle side. I mean, we're not collecting them right now, but we potentially can be adding those in the future. Yeah. So thank you guys. Actually, the most important thing I want to say is please go check the reports. And if you have any suggestion or something you want to see and it's not covered, please let us know and we will try to improve it in the future. Thanks.
Thank you, Sabrina. I don't see any questions, so I think we're gonna go to an intermission for a couple of minutes and then get started with the latter 2 segments of our community call. So you should be able to see a QR code on your screen right now. It's a feedback form that we're basically collecting for some of the community calls, just to see what kinds of things we can do better, what kind of content we can line up that you might find more interesting, and questions around the format and length. Obviously, today we're going a little bit longer because it's been around 1.5 months since the last time we had a call. So there's a lot of stuff to pack in. But hopefully we're going to try to keep most calls at around maximum 1 hour going forward. We'll just pause here for 2 minutes and then we'll get started with the next segment, where Mario from Crypto Manufacturer, one of the node operators participating in the Lido and Ethereum protocol, is going to help us with some troubleshooting tips about how to figure out if you missed a block proposal, why maybe you missed it. Okay, we're gonna get started back up in about a minute. Okay, we seem to be having some technical difficulties with getting the stream started on the crypto manufacturer side, so we're just going to flip the order. We'll start with Manu from Kiln first. The subject matter is the same, just two really different approaches in terms of troubleshooting potential causes for missed blocks. So Manu, please take it away when you're ready.
I am ready. Can you hear me?
Loud and clear.
Okay, cool. So I am Manu from Kiln, and I'm gonna present how usually we analyze block when we miss some blocks. It can happen from time to time. Okay, let's go. So about the technical stack, we run MV Boost, we run a validator client on a beacon node, and in Lighthouse in the following example. We run execution layer client, which is get in the following example, and also we run Web2 signer. How do we process when we miss a block? First, first we retrieve the corresponding slot number and the corresponding slot time. Just after, we try to get all the information related to the get header. And after, we try to get all the information related to the get payload. And we retrieve also what is a relay. Is it flashbot or infrastructure relay or blockthrough or whatever. And eventually, we try to retrieve the block submission into our validator clients, because the validator client is still supposed to submit the block, even if the relay does it. And just after, we reach out the relay on Telegram to get some more information. And yes, and we do some more fine-grained analysis if needed. Just gonna go through an example. So first we have a monitoring tool and an alerting tool which warn us of different stuff, including when we miss a block. For example, here we miss a block at 2 p.m. approximately on slot 6602401 with validator B1 48 and so on. So it's the error, the message box. And so, yes, and for information, our monitoring system is open source on Kiln GitHub repo if you want to use it also. And so it's the first step. So we know we missed a block. And just after, we go to Beacon Chain and we try to retrieve the block, the slot time, so the slot time. So very simple. It's quite a manual process at the moment. We plan to automatize it, but we didn't do it yet. So we retrieve the slot time, and after we go through MAV Boost logs. So in MAV Boost logs, there is a very important log, which is best bid. Best bid represents the bid. So best bid contains the information of what is relay who won the auction. In this case, the relay was Blockthrough because it's written here, Blockthrough regulated. And so we know for this slot, Blockthrough won the auction. Just after the best bid log, there is a get log about the get header. And in this log, there is two very important information. There is a timestamp actually here. In microsecond or millisecond, and so it indicates here this timestamp corresponds to the response of the get header. and the response gets the get header. We get it at 2 p.m. and 35.71 seconds. And because we know the slot begin at 2 p.m. 00:35, we know that we get the answer at t plus 0.71 seconds into the slot. So it's the answer of, it's a response of the get header. But also there is duration. So this duration is the duration of the request. So it's 0.41 seconds. And so we can deduce that the get header request time was at 0.30 seconds into the slot. So we get our information, our time information about the get header. And just after, we do the same for the get payload, if any, because sometimes there is no get payload. And so it's kind of the same information. We have here the post message in the MEV boost logs, which is blinded blocks corresponds to the get payload. The same, we have the timestamp of the response of the get payload, which is 5.17 seconds into the slot. We have the duration of the call, which is 4 seconds, which is quite huge. And we can compute so the get payload request into the slot, which is at t plus 0.89 seconds. And yes, that's all for the get payload. And after, we can go also to the validator client. And in this case, it was Lighthouse. And so we can see we propose our sezzle block at this time 41.733, which correspond to 6.73 seconds into the slot, which is very, very late. And yes, finally, we just summarize this information into this kind of graph. So we can see the slot start at 0, get header request at 0.3, get header response at 0.71. Just after the get header response, our MEV boost did the get payload request. And here we can see a very, very, very long period of time of more than 4 seconds. And finally, at 5 seconds into the slots, we get the response of get payload. And after also we submitted the block ourselves, but it was far too late because with a quite new rule, if a validator don't receive any block after 4 seconds into the slot, he did not vote for this block. I mean, he votes for the block of the previous slot. And yes, so we have all the time analysis. And at this stage, we can conclude as we as node operator, we perform correctly. I mean, in timely manner. We even propose the block ourselves, but too late because of the late response of the get payload. And so, yes, we just reach out the relay, in this case, block shoot on Telegram. We send them this diagram and log if needed. And yeah, and our job as node operator stop here. And sometimes we get into more analysis if needed. And that's pretty all for me.
Thanks, Manu. I don't see any questions right now, but I do have a couple really quickly. So like, how many of these diagrams have you made in the last couple months? Are you keeping track?
I keep track. I don't know exactly. Maybe I don't know.
Is it a KPI now?
No, yeah, maybe 30. Something like 30. Yeah.
Wow. Okay.
Because I mean, I can say almost now. I can say right now maybe 100% of the block are not 100%, but I don't know if you heard the music. Sorry.
No, it's fine.
So we are currently in a offsite with Kiln, and it's hard to find a place where we can talk. Yes, at least I would say 90% of the missed block are due to issue with the node with relayers with relay, and also we have other the other big issue is sometimes when our validator calls the get header very late in the slot, like very late could be more than 2 seconds. We had the issue with Prism. A lot of time we made some measurements about what Prism sometimes take a very long time to do the get header. So we have quite precise measurements. We don't exactly know why yet. It really depends on the validator client. One validator client may perform very nicely, the other very worse, and we try a lot of different configuration, and we don't still yet know why there is some difference between Prism validator clients. But yeah.
Okay, interesting. Thank you. Yeah, it generally seems that like the solution to most of these is call get header and then of course get payload as fast as possible. But get header is the most important, because then in theory, once you've confirmed a header, the relay can even broadcast the block for you. But there's not a lot of tools at our disposal to like force calling it, you know, even after like no bids have been received, for example, to fall back on like a locally produced block right now.
Yeah, exactly. Yeah.
All right, thanks a lot. I imagine there might be a few questions that might come up from this video at a later time, once the recording is made available. So we'll definitely route those to you. And maybe you want to sell your timeline making skills on Fiverr or something, because this is super helpful to me.
Okay. With pleasure.
All right, thank you.
you.
And enjoy the rest of your offsite.
Thank you.
Okay, Mario is up next from Crypto Manufacture, sharing their analysis about how to figure out what went wrong with lost proposals.
Hey everyone, can you guys see my screen?
Yes.
Awesome. Okay, so I'll talk a little bit about our architecture first. On each of our Lido environments, we keep 1,000 keys. We use Vouch as our validator client. Each Vouch has 3 RPC consensus layer, execution layers, servers. We try to use different ones on each one. So we use Lighthouse, Erigon, Teku, Besu, and Nimbus Nethermind. We use the Lido validator monitor in Grafana, so that's how we find out aside from the Discord channel. So whenever we get a missed block, the first thing that I will usually do is go and find the slot or the epoch when it happened. So for example, this one 5 days ago, we miss it. So we can see that it happened at 9:25. So I will just go into the Grafana and get the vouch trace for that. In this example, you can see that it took us, we weren't actually even able to unblind the block, probably because it happened after 2 seconds inside the slot. And then that's how we find out what the issue was, that we just weren't even able to propose the block because we were so late on trying to get the unblinded block.
Yeah, so if I can add to that right quick, now Mario is entirely right that in this case, we didn't get the get header soon enough. Our understanding is that the relays either already have started or will start sending a 400 if the get header comes later than 2 seconds. And then we need to unblind this block, right, within 4 seconds. So we definitely have some very tight timeframes here, particularly since this is running in APAC, Asia Pacific, right, where the latency is a little brutal, to get this done. Thank you, Mario. Continue, please.
Thank you. Another example will be this one from 7 days ago. You can see that this slot, the slot started at 6:26:47, which is pretty much the same time that we started at, but it took us over 2 seconds to get the block header. And then by the time we tried to propose without an action block, we were pretty much just too late. We were able to submit it, but by the time we did that, we were already 5 seconds into the epoch and we were already too late. So this issue seems to be mostly around latency, and sometimes just getting errors from the relays. We checked that per environment. There are some relays that just never send a response back, and because it times out, and some of them are just consistently slow. They do send a response, but they are consistently slow. We have another example here. 7 days ago at 4:44:23. So we started on time, but you can see that pretty much the same issue. 2 seconds into the slot, we still didn't have the builder bid, so we had to go and get a proposal without a bid, but we were too late to do that. By the time we did that, it was already over 5 seconds, and yeah.
Go ahead.
Yeah, I was gonna say that's consistently what we're seeing on our end. We are looking at relays just taking too long to respond or just sending errors, and that basically delays the build of local block proposal and submitting it.
Yeah, so if I can, I'm going to talk a little bit about, thank you, Mario. I'm going to talk a little bit about what we think we're going to do about it, right? So there was a question of how many of those do you have? I admit I don't have a good count. I know these 3, I think we've had like 4 or 5 missed block proposals in the past month, which is too many for comfort for myself. I don't like that. So we did 2 things to start with, and now we're looking at a 3rd for a specific environment. So first, one of the issues we have is that we decided to live in APAC for roughly half of our environments, right? We have some in EMEA, we have one in AMERS, and we have some in APAC. The reason we did this was to help with the decentralization. That comes, however, because we're cross-region. We don't want to be down if one region goes down. That comes with some latency, which is causing some of these issues. So when you look at that red vouch up there, you can scroll up a little bit, Mario, that one, right? That red one means it did not respond. So what Mario did is he went through all our environments and in a manual slog just looked at, are there certain relays that just don't respond, right? Like not all relays are geographically diverse. Some of these exist like in one geographic region and don't have a steering algorithm in their load balancers to get you to a close relay regardless of where you are in the world. And so they just can't respond in time. Those relays we have removed from the configuration. If they can't respond, there's no reason to have them in there. And if we can shave a little bit of time off by not waiting for them to time out, then that's a good thing, right? The second thing we did was, if you can close that again, Mario, and scroll us down a little bit, we have this, you see this mystery 2-second delay here? Like this is where the consensus layer client is not responding, or is not able to get to the MEV boost inside vouch, and it has a 2-second timeout for that. We have like this mystery 2-second delay in here, which Jim McDonald was incredibly generous, has been incredibly generous with his time so far to help us figure this stuff out, right? To see, why is this happening? Why do we have a 2-second delay here? If that didn't happen, we'd be fine. So that was a configuration mistake. It turns out we have in vouch, we have the block proposal strategy of best, but ever since merge, there has been a second strategy called blinded block proposal, which we were blind to. So we had it at default, which is first. And so best is indeed best, but we just didn't have that for blinded block proposal. We only had it for block proposal. We needed to add it for blinded block proposal. So we have added this now for blinded block proposal, which means that now vouch will actually ask all 3 CLs for a blinded block, not just one, right? So this Yeah, exactly. So Izzy is saying you need to explicitly ask for best. That's right. It doesn't default to that, right? We didn't understand that. So we've made that change, which should help a ton. And then the last thing where we are in the process of doing is we have one specific environment, which we call Lido 3. That was our first APAC environment. Because we were finding our feet, as it were, with how do we operate in APAC, we changed the provider for the consensus layer, execution layer clients after a year, which means that now vouchers in Tokyo and the CLEL are in Sydney and Singapore. This is not optimal, right? We're going to move a vouch into Sydney to solve this problem and reduce some of these latencies between the VC and the CLEL. And so really that's what it is, right? It's a lot of blocking and tackling. It's understanding that 2 seconds into the slots, you gotta have the get header done. 4 seconds into the slots, so you have to have that published. And then just, these traces are, by the way, amazing. Jim McDonald did an excellent job by saying, you know, we're not just relying on logs. We're going to give you this trace data here. We're running it into Tempo in Grafana, all open source, really easy. And it just gives us this amazing timeline right here on the screen. And then it is looking at how can we improve the configuration? Are there relays we just shouldn't be using in this environment? Did we miss a configuration parameter like that blinded block proposal best? And what's the latency like between vouch and the CLs? You know, do we need to change our regional makeup a little bit to improve that? Mario, you want to add anything?
No, that pretty much covers everything. Thank you.
Okay, do we have questions?
Let me check the YouTube chat really quickly. I don't see any questions. I just wanted to add that, yeah, indeed, this like detailed tracing from the vouch perspective is really, really, really cool, and I can imagine makes your job a lot easier instead of going log hunting.
That's right.
But I also really like the approach that you guys used, where you were trying to figure out on a per region basis which relays work best, I guess, or first in this case, and kind of tuning the relay selection so that you don't kind of have you know, like sticks thrown at you when you're trying to hop over the puddle.
Exactly, right. And this vouch trace is really what makes that possible, to even have those data to make that determination. That vouch uses the best option from 3 Ethereum nodes, also makes it possible for us to run 100% on minority clients. We don't use Geth, we don't use a supermajority client, we don't like that risk. And so, you know, it unlocks so many good use cases for us.
Yeah, absolutely. And definitely need to get the word out on the explicit best configuration parameter in the vouch config as well. I recall,
Yes,
now that you mentioned it, I recall that I saw it in the Lido validators chat, but we probably need to like ping everybody that's using vouch explicitly to make sure that they're doing it that way.
Yeah, we had it for block proposal, but blinded block proposal, we just completely blanked on that.
Right.
You know, that we needed to configure that.
Yeah, it's a hidden feature. That's why a Tesla has such really great performance.
All right, wonderful. Thank you.
Okay, thanks a lot to both Yorick and Mario. And last, on our last segment, we have Elias or Elias, depending on where you're from or what language you speak or which side of the bed you woke up on, telling us about Solo Stakers, the backbone of Ethereum. Elias, if you're speaking, I think you're muted.
All righty.
There you go.
Can you guys hear me okay? Good. Okay, it sounds like we have a little bit of a delay here. Okay, cool. So I can listen to myself. So what I'm going to do is I'm going to mute my my headphones and I'm just going to go on and rant and then take a long pause until I basically, that's it. Insidious little YouTube tab open, giving me all the feedback in the world. Well, good. We should be good now. Hello, everybody. We're here to talk to you about a piece of work that we did, granted by Lego. Thank you, team, for sponsoring that piece of work. And it's basically an exploration into one of the burning, really, questions around the Ethereum validator operator community, which is how much do solo stakers represent as a total of the population? So I've got my co-founder here, Aris, and CDO at Rated, who's going to get into the nitty-gritty. I'm going to MC kind of the high-level facts, and then I'm going to give it over to him to just talk through really the methodology and the work that we did, pre-processing, post-processing, and how we arrived at the results that we did, as well as a deep dive of the results themselves. The high-level finding is that as of the end of 2022, which is the sample that we looked at, we wanted to have like enough confidence in terms of sort of the data fullness, and not have sparse validators that appeared at the later end of the beginning of 2023. We did this. We started this research approximately at the beginning of March. We found that as of the stake mass is concerned, approximately 6.5 of that, and I believe it's 500,000 validators multiplied by 32 ETH, maps back to solo stakers, which is, from my perspective at least, like a really, really strong backbone. Staking does follow capital power laws, and so it is somehow expected that, you know, solo stakers are going to drown out in sort of bigger capital flows that go to professional operators and different types of setups that way. But still, like, since Ethereum has been built really with one of the core sort of missions in mind, to be able to withstand, like in air quotes squarely, a World War III type event where you know, there's a huge catastrophe and there's this last Nimbus client that runs on a fridge somewhere in Alaska, the network can still eventually like keep processing and providing its service for the world that transacts on top of it. 6.5% is pretty humongous, actually. The more interesting finding, which Aris is going to touch on in the end a little bit more, is that in terms of beacon nodes, our best estimate, and this is based on sort of alpha infrastructure that we've built in order to classify and contextualize information from the networking layer of Ethereum, the lower bound estimate of this alpha sort of infrastructure build is that solo stakers might actually represent 35%, and there's an upper bound estimate that goes, I think, over 70% of the beacon nodes that run in the network, which is quite stark, as you know, in contrast to the 6.5% of the stake representation that we found. And then this roughly maps back to you know, solo stakers running approximately 4 validator clients per beacon node, and conversely, you have professional setups, which we'll classify kind of, and Aris will talk about how we sort of look at those two different classes of operators, north of 400 validator clients per beacon node. So without further ado, I give it over to my co-founder, Aris, to take us away.
Hello. Okay, the scrolling might be a little bit, so if you scroll down a little bit. So basically, the fundamental problem with this data set is that there is no solo staker data set. We may all have like theories of like how a solo staker looks like. And Elias, if you scroll a little bit down, at the beginning of the article, there are like a few hypotheses of where we could look to find solo stakers. People who have graffiti with profanity, but then there are like professionals who do that as well. Then maybe people who just have like performance with a lot of volatility, but then you find professionals to do that as well. then you can look at deposit addresses that have very messy transaction history. So for example, aping shitcoins and trading NFTs and this and that, and then creating a validator somewhere, you could assume that this is run by a hobbyist or like a solo staker. But in reality, you find in all nodes quite a few of those, because based on the different architectures that node operators have in accepting the ETH deposits, you may get all sorts of different combinations. So although we did try to look for like a hard rule, so, okay, we're gonna get like all the Avado and all the DApp nodes graffitis, and then assume that those are the solo stakers and then train a model, in reality, data we're getting at the beginning was crap. Because there were all sorts of different variations. Someone may be running a DApp node and then decide that one day they want to move it somewhere else. So stuff like that. But what we do have is a great data set of professionals. So just take like the Lido registry into account, 29 node operators, 190,000 validators, all very well labeled. And we also have like a very detailed data set of performance characteristics since the beginning, since the genesis of the beacon chain. So what we try to do initially is like, okay, since we know how to recognize node operators, maybe we should build a classifier for that. Feature selection, in order to be able to distinguish between two different professionals, the most descriptive features we were able to find were like volatility metrics. So everyone may have like great performance overall, but they don't go down at the same time. So if we take like standard deviation per day, for example, per operator, you find like different numbers over time, and we can use those to just do some clustering or build a classifier to be able to just group them further, because we may have already tagged roughly 400,000 of them, but there was like a bit that was still unknown. So initially, this is what we did. So we created a classifier based on the data that we have, to figure out for each individual validator, what's the probability to be run by one of the 25 main node operators that have like roughly 10,000 validators each, or some of them have even more. And using that, we're able to create a data set of soft labels. So basically, there are 350,000 that we know, and then maybe another 150,000 that we assume they're probably in that category. And we tag and check all of them out. Then we were left roughly 50,000 validators after that. And then the exercise at this point is try to figure out if there are like further patterns that we can identify to just reduce this even further, right? And we try some clustering. So this graph is like UMAP is a tool that you can use for like clustering, various different clustering tasks. It produces those really beautiful graphs. And actually red is like super high fidelity professional operator, and the blue purplish is the solo stakers, and there are like all sorts of flavors in the middle. After running a few iterations of that and training this model with XGBoost, we ended up splitting the data set into two different parts. So there are some validators that we know are solo, and there are some that we assume that might be, there are some that we know are professional, some we assume that might be solo. And in order to actually train a model, when you have like partial confidence on your training data set, you can use various different techniques, and one of them is soft labeling. So instead of like saying, okay, a pro is a 1 and a solo is a 0, the other way around, you can say that a pro is a 0.1 and a solo is 0.9, and then the model will not penalize itself too much if it gets something wrong during training. There are all sorts of different machinations there in order to tune a model, and with how we trained it and the faults that we have created and how many iterations and stuff like that. But I suspect I'm going to skip that because we're out of time. And after running this process on the whole data set, we had a prediction per validator. But even that may have like error in it. And actually, if someone wanted to, create a product that addresses like this particular market, with a validator index, you cannot really do a lot. So what we did on top is we grouped the data per deposit address. So assuming that there is a deposit address with like 4 validators, if 4 of them are predicted to be solo and 1 of them is predicted to be professional based on like the performance on chain, we assume that this is like a solo staker. So we take the majority. And after grouping all of those together, we try to find some sort of way to validate our results. And this graph that we're now seeing is like the aggregation of everything into like one graph. So we can see that the model is making confident predictions. So you will either get a deposit address at the very left, it's like this is definitely professional, or at the very right. And there's like a sort of gradient in the middle, but this is like a smaller one. The majority is going to be either left or right, which indicates that the model has learned some sort of structure and is able to make confident predictions. But in order to validate it further, to make sure that we're not smoking crack here, and this is actual useful data, we try to look at various different patterns that are kind of known that they belong in a certain category. For example, like the Avado and the DApp nodes of this world are mostly solo stakers. There are all sorts of different variations that can exist, including people moving a validator from like an Avado to an EC2 instance. There are things like that that happen in practice. But we could see that those kind of graffitis are mostly predicted to be solo stakers, which is quite encouraging. We can see Rocket Pool that's split. And that kind of makes sense because if you look into Rocket Pool, quite a bit of it is run on all nodes. And you would expect that you have like the solo stakers on one end and professionals on the other end that are running stake for maybe people that are solo stakers themselves, could be solo stakers themselves, but they have chosen to just use a professional to run the stake. And Coinbase is the extreme example that they have created like a huge number of deposit addresses due to the way that they create the validators, and they are almost all predicted to be professionals. We try to get some additional data sets on top to get like as much confirmation as we can. So we looked at POAPs for various different solo staker events, and we brought those things in. Also, we looked at known ENS addresses where they resolve, because this is not exactly foolproof, but most professionals do not really use an ENS tag deposit address. Most of them are like automatically generated through like some sort of system. And this kind of pattern is mostly found in solo stakers. And after we did like all of those different charts, create a big spreadsheet, and then there was quite a bit of mechanical Greek and mechanical Lido. We looked into like a bunch of results to figure out if something is wrong. Afterwards, at some point during the process, there was the withdrawals dataset that would actually merged, because withdrawals were enabled. So we got like a whole new dataset that we could look at. Thankfully, the model was good enough, so we did not find any irregularities, and loads of withdrawal addresses that had like loads of stake on them end up being in the professional side of the spectrum. So those are the final results. There are various different ways to slice it, but in reality, you could treat this as a binary classifier. So like over 50%, you can say that, okay, this is likely a solo staker, and below 50% can say that it's a professional, and roughly 6.5% of the validators were predicted to be solo stakers. And although this sounds like it's not a lot, what's extremely interesting is then we looked at peer-to-peer data. And in this set, out of a sample of 7,200 beacon nodes that we found were relaying at the stations, because there are like all sorts of different ghosts that run on the peer-to-peer network. And if you just look at the number of ITVs, you get very large number, but many of them are just out of sync, or they're not running anything, or just listeners like Army Arma that are not particularly useful to the network. And out of the ones that we're able to identify as running a beacon node, 2,800 out of the 7,200 in the period of time that we looked at, we were able to map them back to a solo staker. And then there is like a chunk that's left, which is the difference. Out of them, we were able to map roughly 700 into known node operators, and the rest is unknown. And this is where we get the bounds of our prediction. So we're able to identify 2,800 as solos. We're able to identify roughly 700 as professionals, And then there is the other category, which may as well be backup nodes from professional node operators, or there are like outfits like us, for example, that we're running full nodes for like archive purposes and data purposes, etc. Still part of the network, but not running any validators. And still, though, the result's significant. So even if AWS and Google Cloud and all the cloud providers tomorrow go and just turn off all the validators that they know of, still the network will have quite a few bigger nodes to continue running. And I guess that's it.
Thanks, Aris and Elias. That's really, really awesome. So number not so big compared to like the total market, but actually super vital
stuff.
and important to the network. Does that sound about right?
Yeah.
Also the heat map is really, really gorgeous. We need NFTs of that. I don't know if you guys are doing another raise, but maybe you can just sell NFTs instead. What would you say was like one of the most challenging aspects of doing this analysis, apart from the fact that the data set didn't exist to begin with?
I guess that was the hardest one. So the fact that we were trying to predict something of which we had 0 examples of. There was quite a bit of work in the feature selection to just go, because we have like lots of different data points we could use just to figure out something that has predictive power. That was challenging. But then the most difficult part was no labels for solo stakers. There were a few data sets out there that we looked at, but then we found all sorts of things that were wrong in them, like including liquid staking pool deposit addresses in there, etc. So we couldn't trust anything out there, so we had to build it from scratch. And I guess starting with no data is the hardest part.
Makes sense. Thank you. I don't see any other questions right now, and we have gone quite a bit over, so I definitely want to be cognizant of your time and also the fact that you presented last. So thank you so much for sticking around. I think we'll record the session. I'm sure there's going to be a lot more questions once the recording is out and people get time to digest the analysis. But super like interesting, I think, and vital to understanding the actual picture of staking, of entities, and of the importance of solo stakers on the Ethereum network. So thank you very much for doing the hard work on this. All right, that's it for today's call. Thanks everybody for bearing with us through like these 1.5 hours plus some delays. The next call will probably be sometime towards the end of July. We'll be skipping the end of June because there's a lot of conferencing going on. So we'll see you around then. Thanks everybody.